Okay, hi everybody. Hopefully those first few problems that you tried the last couple days went as smoothly as they possibly could. I know that this integration by parts is kind of a complicated thing, especially when for one aspect of the problem it feels like we're integrating, and then another aspect we're taking the derivative, but the overall problem is an integration problem. So we're going to pick up where we left off in the notes. We're going to do the next two examples, and then I just have a handful of problems for you to try here tonight. Okay, now this first one that we're going to do, it's very similar to the very last one that we had done a couple days ago here on the notes. Okay, so if you remember, our steps are to look at the two things that are being multiplied together in the original problem. We are going to choose one of those items to be u, that'll be the thing that we'll be taking the derivative of, and then we'll be choosing the other piece to be dv, and that'll be the piece that we're going to be integrating. Okay, a rule of thumb would be you want to pick the easier factor to be u, something that when you take the derivative of it, it's going to be pretty simple. And the reason that you want that to be the case is because that's going to create a very simple du for you. And if you look over here in the integration by parts formula, we need to keep this part something that's going to be really simple because we're after needing to integrate that, okay? And then if a piece feels like it's more complicated, you would want to choose that for dv. But I will say on this particular example, as the one that we had done before this, we said if natural log of x is one of your factors, you have no choice. You have to choose that to be u, because we only know right now how to take the derivative of natural log of x. We cannot integrate natural log of x. Therefore, you would not want to choose natural log of x to be dv. Okay, so we're going to make the x cubed along with the dx. That's going to represent dv. Okay, so in our second step here, we're going to differentiate u. We know that the derivative of natural log of x is 1 over x, and then I'm going to write that by pulling that x up to the top, swinging the dx to the other side. I'm going to circle these things as we find them. So there's our du, here's our u, this was our dv, and then we're going to go back and we're going to be integrating dv, so that becomes v, and then we're going to integrate, oops. Okay, so we're integrating both sides here. That gives us v, and then this is going to integrate to 1/4 x to the 4th, and that'll be v. Okay, and we're not going to put the plus c for the moment here. Okay, now I did write the integration by parts formula over here. Okay, and so we're going to use that, make our substitutions here. Okay, and so on the left side, this u dv, okay, that's actually just these two original pieces that were in the original problem anyhow. Okay, so that's going to be integrating, and I'm going to switch the order up because it's nice to kind of put the natural log of x second. Okay, but these pieces here make up the u and the dv. Okay, now on the right side, this is where my answer is. There is a little bit of a pattern to this, and the pattern is, it kind of goes catty corner here. You multiply u and v together, so that's going this direction here. So I'm going to multiply those two pieces together, and again, I'm going to kind of switch the order just a tad here. Okay, and then minus, now we're integrating, and we go this direction. Okay, like that, and it's v du, these two pieces multiplied together. Okay, now if you've got two separate x's here, do not integrate just yet. These terms that have the x in it, those variables need to be combined together. We're going to add those exponents together first before we integrate. So we're really integrating a 1/4 x cubed in that section of the formula. Okay, and I'm going to hold the 1/4 there. I'm going to leave a space, add 1 to the exponent, multiply in front by the reciprocal, and on this side, this is really just the original problem is what goes over here. Oh, I guess I could have waited one more step and wrote that down here. Okay, and so then the answer to this has this 1/16 right there. Okay, that problem was really just kind of review of what we had talked about just a couple days ago. The problem before it in the notes was really, really similar to that. But I just want to do one more of those just so we kind of get the hang of it here. Okay, this next example, it gets a little bit more complicated, okay? I am going to have you change from what the original problem was here in the notes. We're going to use this as our example, okay? And you'll notice what immediately looks different about this is we still do have like two things that are multiplied together, okay? Two separate factors, and we'll need one of them to be u and one of them to be dv. But in this example, both of these pieces are quantities, okay? So I'm going to choose u, I'm going to choose dv. And I kind of want to follow this rule of thumb here. If one of the two pieces is more complicated, then that's the piece that I'm going to choose to be dv. Okay, and so as I compare these two quantities, the one that's more complicated is the one that has the bigger exponent on it. So I'm going to make 3x plus 4 to the 8th, the dv. Remember, dx always goes with that. And I'm going to make the more simpler quantity, the x minus 2, be the u. Okay? All right, so now I'm going to go down here to step number 2. Let me erase this and move this up a little bit. Okay, and remember how this works here. You are taking the derivative of u to get du. We are integrating dv to get v. Okay? So du would be derivative of x is 1, derivative of negative 2 turns into a 0, and so then I bring the dx rather to the other side, and I have du equals dx. Okay, I'm going to go ahead and circle this, I'm going to circle this, I'm going to circle that. Okay, now to get v, this is where we're going to be integrating both sides here. So we're integrating dv. We're integrating this side here, and here's where things are going to get a little bit more complicated. We know that when you integrate a 1 dv, that gives you v. But here's where we have a little bit of an issue here, is how to integrate this. Okay, this is where we left off in chapter 5. We learned that if you're integrating a quantity, this requires integrating by substitution. Okay. Now, when we did substitution, we always used u's. But since we're using u's in this integration by parts formula, it would be very, very confusing if we also chose u's to integrate like this right here. Okay, so I'm going to go with a completely different variable just to make this a little simpler here. Off to the side, I'm just going to make a little note here. I'm going to integrate by substitution. Okay. And so instead of using a u, I'm going to use a p, okay? And I'm going to let p equal what's in the parentheses, okay? I'm talking about this part right here, 3x plus 4. That's going to be what p equals, okay? Okay, and then we take the derivative of p, that would be dp over dx. The derivative of 3x would be 3, and that means dp would be 3dx, okay? This is what I'm using to help me integrate that. Okay, so I'm going to swap out this 3x plus 4 right here for a p. Okay, so I'm going to put a p there. That'll be to the 8th power. Okay, and I have this dx right after it. Okay, now remember, I need this to be a dp. So I got to look over here and say, well, what is dp equal to? Well, dp is equal to a 3dx. But if I look at what I have here, I don't have a 3 in there. Okay, so I need to insert a 3, and we said we counteract that by putting the reciprocal of 3 in front 1/3, so that technically we're really just inserting a 1. Okay, and then I'm going to exchange all of this 3dx. That matches this, so I'm going to exchange that for a dp. This is just integrating by substitution here, okay? So now we can integrate p to the 8th, adding 1 to the exponent, multiplying in front by the reciprocal. We end up getting v to be 1/27th p to the 8th, which would be, if we took the p out and replaced it with right up here where we said what P really is equal to. I'm going to just draw a little line here so we see where we got that back from right there. Okay, and I'm going to circle this as our V. Okay, so now we have all 4 parts circled here for our integration by parts formula. So I'm going to go ahead and write down generically the integration by parts, by parts formula here. Okay. All right, so there's all the pieces we need. Okay, we know on the left side here, this is just u and dv, which when we write those, that's nothing more than us just really writing what the original problem was to begin with. Okay, and then we start making our substitutions for uv, and we say it's kind of a diagonal here, so we're going to go like these two things get multiplied together. Okay, and I am going to write it in just a slightly different order, so at least the 1/27th is in front. Okay, and then notice it's always minus right here. Okay, so we're going to do minus, and then it's v du. I didn't write that very nice. This is a v here. Okay, and so then these things get multiplied together. Okay, v, and there's an integration symbol there, and du just gets exchanged for a dx. Okay, now remember, what's on the right side is our answer, but if there's still an integration symbol, like right here, then we have to perform this integration. Okay, so all of this, the 1/27th, I'm just copying this part down. There's nothing more I can do with that. Okay, but if we want to integrate this, look at what we have here. This is another integration by substitution. Now you don't have to write down all the work again. We already have all those substitution pieces right up here in this box. Okay, so we're going to look back up in that pink box here. I'm going to swap out the 3x plus 4 for a p, and then I'm going to insert a 3 here, which means I need to insert a 1/3 out in front. Okay, and that's so that this can all be swapped out for a dp. Okay, I know this is like a big problem because we have to just sort of keep rewriting this. Okay, so now that gets swapped out for a dp, and I think we're good to go ahead and actually integrate this. Okay, because what we have right here, this is now something super easy to integrate if we're just integrating like this p to the 8th. Okay, so again, copying this down. Okay, I'm going to go ahead and multiply this 1/3 and 1/27th together there. Okay, if we multiply those together, that gives us 1/81. Leave a little space. I'm going to add 1 to the exponent, so that's p to the 9th. Also going to put a 1. Oh, yeah. Oh my goodness. Grr! I'm so mad. Okay, I made a mistake, which you guys probably saw way back yonder. Grr! Right here, for some reason, when I went, oh, I'm so mad, from here to here, I don't know why I had that as an 8. That should be a 9. That should be a 9. This should be a 9. This should be a 9. Okay. So that means this was a 9. All right, so in this step, when I integrate that, that's a 10. Blasted. I apologize. Grr. Okay, and then I'm going to put my plus C. Okay, and I'm going to make this my last step here. So I'm going to do 2 things at once here. I'm copying all this down here. Okay, my fraction is going to be 1/810. I'm going to take out the p. Okay, you're looking right up here. This is where you're going to put in 3x plus 4 back in place for that. And I'm going to label this as the original problem over here on this side. And this is what we're saying then the answer is to this. Woo! Okay, so there's a few problems for you to try. They're not all like this, but there are some that are like this. And I just need you to message me if you guys are having questions or trouble with it, because it is complicated. And I apologize about my mistake. And let me know if you guys have questions. Thanks so much. We'll talk to you later.